What's up, everybody? I'm Kevin. I'm a sophomore at the University of Pennsylvania. Um, I've done some research in the past in natural language processing, so I thought I'd share a bit about my data science experience with you guys.
I'm Terry. I'm a sophomore at Western University, and I'm planning to do a dual degree in business and computer science. And I'm currently working for an e-commerce company and working with small businesses.
So yeah, during this presentation, hope just to give you guys a bit of an overview of data science, and also give you guys a example we can work through together, so you guys can actually see a data science project from start to finish.
Yep. Okay, so before we get started, we're going to introduce quickly just what kind of is data science. And the thing about data science is it's not exactly like one entity, but it's kind of a field that has a collection of a lot of different fields such as like big data and machine learning. These all fall into kind of the category of data science. And what these things all have in common is that they all use data to they all use large amounts of data to like make predictions, to gather information, to model, and to solve certain problems.
Yeah, here's a quote from Hal Varian. He's a fairly well-known economist at Google, also a mathematician. He says that data science is really important, and as we're going to show you today, it definitely is really important.
All right, so why should you be interested in data science and what can it do for you? Um, well, if you ever want to pursue a career in data science, it's actually a very lucrative and sought after career in a growing field. And Glassdoor actually ranked being a data scientist as being the third best job in America this year. And in the previous few years, I believe it's been ranked as the best job in America. So it's very in demand because you work with a lot of growing technologies such as machine learning and like big data. And there's a lot of jobs that you can get in this field, such as being a data consultant, working with machine learning, and applying all this data to make models and applying it to solve real problems for different businesses and corporations. So overall, it's a great career and something you should definitely look forward to.
Yeah, so I'm just going to give you quite a quick overview of some of the steps in a data science project. So first off, you need to get the raw data. This isn't as easy as it sounds because a lot of the times people won't give you the data just for free. You're gonna have to get it yourselves, whether through scraping a website or collecting data about the natural world, maybe soil moisture or atmospheric pressure, whatever it is. You need to get the raw data. And once you get the raw data, you need to realize that we live in a probabilistic world. We live in a world that's determined with by statistics, and because of that, there's gonna be data that's missing. There's gonna be data that's bad. There's gonna be data that's uh, messed up. There's gonna be data that someone else messed up with. There's gonna be human error. There's gonna be all kinds of error. And so what you need to do is you need to take this raw data and you need to clean it. You need to get it into a form that's both easier for you to understand and as well as for the computer to understand. So that's the first step in data. That's the second step in data science. You need to take the raw data and you need to turn it into clean data. So what you want to do is you want to explore the data. So what I mean by this is you want to better understand the data. And how you do this is you're going to just run a couple commands by yourself, maybe make a couple graphs to kind of better understand the data. Because when you better understand the data, you can make better models. And then what you want to do after that is you want to extract features. So a machine learning model needs numerical features. It needs so what I mean by feature is, for example, like if we're doing stocks, maybe the stock price, the date. Those are features. They're attributes of the data. And you need to make sure all these attributes, all these features are numerical. So you can't have any letters, you can't have any words. You need booleans or you need numbers. And then finally, once you have a data set that is numbers that's usable for machine learning modeling, then you want to model. So you want to pick the best machine learning model you can for what you want to do. And what a model does, it will make a prediction about the world. So it will predict the stock price on Tuesday. It'll predict how much Tesla's going to drop. It'll predict what the weather's going to be like tomorrow, stuff like that.
So yeah, as Kevin said, there's a lot of steps required, and it may seem like a lot of work and effort. So you might be wondering why you would actually use all this. Well, luckily for us, we have excellent computers nowadays, and the technology for processing and for handling all this data keeps improving, which allows computers to handle um, large amounts of data that would be really difficult for, say, one person looking at a sheet or a document full of thousands of lines of data. It would be very difficult for him to do. For a computer, that's easy. So with computers, what they can do is they can create algorithms, and with algorithms, they can allow these computers to make better and faster decisions than a human. And with machine learning, a computer can basically learn from itself and learn from its mistakes, so they can constantly improve on these algorithms and optimize it basically. And this can all be done automated, which would take a lot of strain off of working all this manually. And even if there is a problem with, say, the algorithm or any of the data or anything, the computer models can be adjusted and they can always be tweaked and optimized so that you can always improve and fix a lot of the issues that you run into. So some of the common languages that we can use in data science include Python, which I'm sure you all know. R is a language that's kind of similar to Python. And there's also MATLAB, which is a language that's more used in kind of academia and research. But all of these languages are very commonly used. We're going to be using, for our demo, Pandas, which is a library in Python today. And aside from these languages, there are also a lot more, such as Julia and RapidMiner. So in short, there's a lot of different languages you can use in data science.
Yeah, so let's talk about some of the common tools that we can use with data science. So to get the raw data, two examples to get the HTML data would be XPath and Beautiful Soup. So this is to get data from websites. Maybe to get raw data, you might want to use a thermometer to get the temperature, or maybe you want to use an atmospheric gauge to get the atmospheric pressure, whatever you want your raw data to be about. You need to use something to get the raw data. So these are two examples of toolkits, XPath and Beautiful Soup, to get raw data. Now to clean, to explore, to extract the data, we can use Pandas, which is just a data science framework. This is what we're going to be using today. NumPy is really great with numbers, with matrices, with tensors. Its strength is in computers like numbers, and this does numbers well. While SQL and Spark SQL are they're nested data structures, so it's more logical. It's a more logical way that humans think. Spark SQL, the Spark part is a distributed platform. So instead of shoving everything into the RAM to run, Spark SQL will distribute the operations across multiple processors or multiple computers or whatever to make in parallel to make running the computation faster. Because when you work with large amounts of data, when you work with big data, one of the oftentimes the challenges is that you might break your computer, or it might take forever to run. And then SciPy is once again just really great with numbers. And then Matplot is a software so you can make graphs. And then for modeling, which is the machine learning part of data science, we can use Scikit or Keras, which are more generalist. Scikit's really great for a lot of the simpler algorithms. Keras is really great for neural networks and deep learning. And then TensorFlow is really great with signal processing, with images and stuff like that. So today we're just going to be using Pandas and Scikit. I also want to talk about some of the common machine learning or data science modeling techniques. So machine learning, there's two different types. There's unsupervised and supervised machine learning. So unsupervised focuses more on it's more of like an unstructured approach. You just try to get like whatever you can out of the data before, and then whereas supervised is more, you've given it a structure, like you want it to predict the housing prices. So given like that structure, you can do machine learning. So it's kind of like supervised. So an example of unsupervised machine learning is dimensionality reduction. For example, like principal component analysis. We're going to get into that later. And then for machine learning algorithms, we could talk about there's regression, this classification, which is classification basically like is the photo a dog or a cat or a horse, or like is it going to be a snow day or not? And then you can also we could also talk about neural networks, which is a more advanced method for machine learning. It's kind of more deep learning. Yeah. So the meat of today's presentation is going to be, I'll be showing a demo of how we can apply data science. So let me just switch over to that.
All right. Meanwhile, if you guys have any questions or anything, feel free to just put them in the chat or to message one of us on Discord, and we will get back to you.
Can everyone see my screen? Okay, so I'm going to be talking about sports prediction. So I'm a big fan of basketball. I probably spend an unhealthy amount of time following basketball and the NBA in particular. So I was wondering, how can we predict if someone's going to make it to the NBA or not? So given a college player and his stats, will he make the NBA? And that's my question. So that is what we're going to be figuring out today. If we can accurately predict whether or not someone can make it to the NBA. So first step, we have the first step with any machine learning project, obviously you have to install, or where you have to set up the libraries that you want to use. So obviously Java. And then today I'm going to be using NumPy, which is like the number stuff, pandas, which is just the machine learning framework. I have some graphing stuff, and then I have date time, so I can handle dates. You don't have to don't get too bogged down by this stuff. You don't really need to understand what it means. Just when collab or when Python tells you that you need to install something, just install it. Okay, so I've provided two CSVs. Could someone confirm that people have
Oh yeah,
them?
I'll just put those in the Discord right now. So they should be under the workshop talking Q&A. I'm just gonna add them right now.
Okay, so you guys should be able to play with these data sets when you're done. So I use, for the first data set, is a data set of all the men's basketball players from 2000 to 2019 in NCAA Division One. They're all, I adapted a tool from a guy called Creswell on GitHub to get all this data. So that's a raw data part. He built a scraper with I think Beautiful Soup, and I used that to get the raw data. And then for the NBA player data set, I got it from Kaggle. So Kaggle is a data science website that oftentimes has some better formatted data. So what a CSV is, basically, just think of it as an Excel spreadsheet. So there's rows and columns. Yeah, that's basically it. And then so what pd.read CSV does is it takes a CSV file and it converts it to what pandas uses. So pandas' basic data structure is a data frame. So this is what a data frame looks like just by typing in. So I called it MBBDF, so men's basketball DF data frame, and I called it NBA data frame. So just by typing in MBBDF, pandas will show you what the data frame looks like. So in this case, you can see that there's an index here. This is a column called team, which says the team of the player. The player says the name of the player, how many games they play, minutes per game, field goals per game, and whatnot. So then, and then next step, you just want to drop any duplicate rows. So maybe like Olamide Peterson appears twice, and it's like the same year and same stuff, and it's just a mistake in the data. We want to drop those. We want to drop those rows. By the way, if I'm going too fast for anyone, just please shoot a message on Zoom, and someone will let me know that I'm going too fast, and then I can slow down and explain stuff. And then so that next we want to talk about some of the basic operations you can do with pandas. So this is called slicing. So by typing in the name of the data frame and then including the name of a column in square brackets, it's going to give you a slice out of the data frame. In this case, I want points per game. So points per game is this column. So what the slice operation does, it basically just takes this column and returns it as a series. So this is what a series is. It's basically just a column of a data frame. Now, if you want it to, instead of returning a series, you want it to return a data frame when you slice the column out of the data frame, what you want to do is enclose it in 2 square brackets. And see this, in this case, it's going to return a data frame. And then we can also do stuff like Boolean logic. So this is a series called of team. So this is MBBDF team is this series. And then if you equate it, if you put like logical like double equals Harvard, then this will give you whether each of the elements of the series is Harvard or not. So if it's false, it's obviously not Harvard. So then what can you do? What you can do with this is you can write MBBDF and then you can enclose this. If you enclose a Boolean series, so this is a Boolean series. This is this series. You can enclose a Boolean series inside square brackets MBBDF, and this will give you every single row for which the Boolean series is true. So it gives you basically all the players that played for Harvard. So yeah, and then what else can you do? So you can sort by points per game. So in this case, what I do is MBBDF, and then so Python gives us a sort values function for data frames, and then I sort by points per game, and then I want to go descending. So I want to see who scored the most points per game. Chris Clemens did. Fun fact, I think he's actually like only 5'9" or something, if memory serves me right. So it's quite incredible. He leads all NBA scorers in points per game for the last 20 years. Yeah, and you have like Jeremy Fredette, Steph Curry. Yeah. So yeah, going on. We also want to figure out because we want to figure out which year college players, like how many years college players played in college. So some people are only going to play 1 year and then they're going to go to the NBA, and some people are going to play all 4 years and not make the NBA. So this really matters for NBA teams because they want to see who has the most potential, right? And if you're younger, that means you have more potential. So we want to see how many years they played in college. So before we do that though, we need to turn. So notice how some people have not a number for games. So what that means is that's Python's way of telling you there's no data for that. If there's no data for how many games they play, that means they played 0 games. So what I'm going to do is I'm going to turn all these not a numbers into zeros. So how do I do this? What I do is I say I apply a function to the game series. The function I apply is a lambda function. It's an anonymous function that apply applies a function to every single element of a series. So for any element x, it becomes 0 if x is null, if pd dot is null x. If x is null, it becomes 0. Otherwise, just keep it as x. So then we can look at what this gives us. So now all the games, it's 0 instead of not a number. Machine learning algorithms don't like nans, so you want to turn them into whatever makes the most sense, or you just want to remove them. That works too. So next, what we want to do is what I want to do is I want to figure out so to count how many years every single player played in college. Basically, for every year they played, there's a row in the data frame. So basically, we just need to count the number of rows there are. Does that make sense to everyone? Okay. So then what we can do is we can do a group by. So what a group by does is you can say, I want to group all the rows by a certain column. So in this case, maybe I chose a group by player and team. So basically MBBDF, 2 square brackets in these 3 columns just gives a data frame of only these 3 columns. And then I'm grouping by player and team. So I'm first grouping all the rows by the column player, and then I'm grouping all the rows from this by the team. And I'm doing grouping by players and then team because some different players might have the same name, but I figured that there's probably a really low chance of players and having the same name and the same team. So then we can look, for example, a Darren Duncan from Coppin State only played 1 year in college, whereas Austin Calhoun from Bowling Green State played 4 years in college. So then we can and then because G doesn't really mean anything in this case, I want to change it to something that's more meaningful. So what I'm going to rename, I can rename a column. So I'm going to rename G to year 2 NBA. So that means like how many years they played before they tried to go to the NBA. Obviously, if they never tried, then they probably played all 4 years. So then what we can do next is although I don't like how it just says 1, 1, 2, 4. I want to make it make more sense to me. So what I'm gonna do is I'm gonna put a I'm gonna convert a 1 to freshman, 2 to sophomore. So they left for the NBA as a sophomore. They stopped playing as a sophomore. 4 means senior, and then apparently you can play as a graduate student. So some people play for 6 years. So I just call them super seniors. And then so I made a Python dictionary to do this. So one corresponds to freshman, 2 corresponds to sophomore, and so on. And then I can 4 corresponds to senior and whatever. So then I can make a Python function that says convert year. So it takes in an integer I and it just returns the corresponding element in the dictionary. So in this case, once again, I can apply the convert year function to every element of year to NBA, which returns obviously freshman, sophomore, senior, junior, senior, whatever. And then so obviously that worked now. So now what I want to do is I want to merge the data frame. So I want to, for every single player and team, I want to be able to have also the year to NBA column inside this data frame, inside the original data frame. So I want a column right here that says what year they left college or they stopped playing college basketball. So to do this, we use a merge operation. Depending on the data science framework, it might be called merge, it might be called join or whatever. Basically, so I'm taking year df. So this is what I call this data frame. And I'm going to merge it with men's basketball df on an inner join. So inner means that I'm taking stuff that satisfies both sides. So only the rows that have the same team and the same player. So the left data frame is year df. So on the left, I'm merging on player and team. So I'm finding corresponding players and teams in MBBDF that have the same name and team. And so on the right, I'm also merging on player and team. So hopefully that the merge, how merge works is clear enough. So now after I've merged, see how there's now a year to NBA column, which is like freshman, whatever, senior. It tells you basically, even if this is a Tory Shine's first year, we know he left for college as a sophomore. However, it's not really useful to know how a Tory Shine played before his last year, because we just really want to know how he performed in his last year before the NBA got to look at him. So then what we do is what we want to do is we want to take only the last year for every single player. And so the last year is just the last element that name appears in the data frame. So another way to handle Python's data frames is you can just use normal Python. Pandas' data frames, you could just use Python. So just a normal Python for loop for I in range 0 all the way to the length of the length of the data frame. And then for every single element, so the MBBDF player, so the ith element of the player series of MBBDF, if it's equal to the next element. So if this element is equal to the next element, then you drop this one. So it only leaves the last one. And hopefully you can see why that works. And then now we can look at what our data frame looks like now. So it only shows every player once, and more importantly, it only shows the last year they played. So it shows Austin Calhoun only his senior year of college basketball. So yeah, and then going on, I just want to show you quickly how to make a graph. So in this case, I'm looking at when people left college basketball. So a lot of them only played 1 year in college basketball, or 2 years. Very few to actually play 3 or 4 years, and even less 5 or 6 years. So to do this, I'm just taking the columns that are useful, turning that into a data set. I'm grouping by year to NBA. So year to NBA is freshman, sophomore, senior, whatever. So there's 6 different categories, and I'm grouping them. And then I can count how many there are of each, which tells me when people left for the NBA. And then then we get this kind of graph. You obviously I wrote that the kind of bar graph I want is a bar graph. For a different plot, you might want a line graph or a scatter plot or whatever. I think I'm pretty sure Matplot supports all of these. Yeah. And generally for a data science project, you want a lot of explorations. You want a lot more graphs. I only have one because I'm trying to save some time. But generally you want a lot of graphs, as many as you can, to better understand the data. So then next I want a list of all the NBA players. So remember at the very top, so right here, I took in and also data frame of all the NBA players and their stats. So what I'm gonna do with this is I'm gonna take NBA DF. I'm gonna take so there's a column in that data frame called player name. It's the name of all the players. So I'm gonna take that series and I'm gonna turn it to a list. So the pandas to list function does that for pandas series. It turns it into a list. So as you can guess, the NBA list basically gives you all the basketball players. Yeah. So what you can do with this is and then I have a list of all the basketball players now, right? So what I want to do with this is I want to add a column in my data frame that's called NBA. What I want it to do is basically say false if the player never played in the NBA and true if that player did play in the NBA. So this is another way to make a new column. So basically just call the new column NBA and then tell it what it's defined by. So in this case, I'm going to populate the NBA column of the MBBDF by taking the slice, the player series, and I'm going to apply a function to each element of the player series. I'm going to apply a function to each of these names, and the function is an anonymous function. So it returns true. So NBA, the corresponding element of the NBA column is true if this element is in this list. So if you played in the NBA, otherwise it's false. So hopefully that's clear enough. So then if we look at our data frame now, we have an NBA column. It's false if the player never played in the NBA, and it's true if they did. So now we're done with data cleaning and exploration. So normally you'd have a lot more exploration than me. You want a lot more graphs. You want to find like the maximums, the minimums, whatever. But I just want to get through this so I can talk about more machine learning and stuff with you guys. So let's go to feature engineering. So as I said before, feature engineering is turning data into numerical or better, easier data that can be easily handled by a machine learning algorithm. So first, what we want to do is machine learning algorithms don't like columns that are nans or nulls. So I'm going to write a quick script to find what percent of each column is null. So in this case, I messed up, and there's supposed to be a column here called ranker that's all null. I'm not sure why that was in the original data set, but it's all null. So then if something's all null, then it's a useless column, so you just want to drop it. And then the name column, this column doesn't really have much value because you can't really turn this into numerical or anything. So then I just drop the name of all the players also. So I remove it from the data set. So I remove this column and this column from the data set because I don't need it anymore. So now let's talk about how to handle categorical data. So categorical data is data that can be defined as belonging to a category. So obviously there's data that's numerical. So for example, game started, that's a numerical category. It's how many times did whoever start the game. That's like you can have like a number. Whereas for example, like the name of the team isn't really numerical. It's more of a category. Like you belong to Coppin State or Tennessee State or Bowling Green State. So what you want to do with that is you want to how do you handle categorical data? So in this case, I've identified 3 places where we need to handle categorical data. So the team, year to NBA, and also year. So year might seem like numerical data, but really it's categorical data because year is more of the what year they get drafted. It's a draft class, not really. It's not really like 2013 versus 2012. That doesn't really have any like meaning numerically. It has more meaning as in like he was drafted in the year 2013, which is a different category than getting drafted in the year 2012. So how do we handle categorical data? Because it's text, right? So what we want to do is for every single category, we're going to make a new column. The column for the corresponding element is 0 if that player never played for this team. It's 1 if they did. So for example, for Adair and Duncan, the Coppin State column would be 1, and for everyone else, it'd be 0. Hopefully that makes sense. And we're going to do that for each of them. So this is called one-hot vectors. If you want to clarify this, just please let me know right now, or you can just search it up. So in pandas, one hot vectors are called the function to make one hot vectors is called get dummies. So I want to turn the MBBDF, this slice of team, into one hot vector. So I want to make a column for every single team possible. These columns are going to be zeros and ones. It's going to be Boolean. False if the player never played for them. True if they did. I'm going to do the same for year and year to NBA. And now that I've done that, I can just drop the team year to NBA and year columns because they're useless now because they're not numerical. And then finally, what I want to do is for all the nans, it probably just means that it's zero. If field goal percentage is not a number, it probably just means that they didn't shoot at all. So it's a zero. So what I'm going to do is I'm going to change all the nans to zero. And there's a really easy function to do that. It's just mbbdf dot fill na, and I'm going to fill it with zero. And now we can look at the data types of all the columns. And generally, this is an excellent way to check at the end to make sure all your columns are numeric. So now we can look at our columns. So we have obviously the couple the couple columns we already had, but now let's look at some of the other ones. So this is what one hot vectors look like. So for example, the team Abilene Christian. These players all didn't play for Abilene Christian. These players all didn't play for Air Force. And then it'll be a 1 if a player played for Akron, and a 0 otherwise, and so on. So we have a lot of teams. So there's a lot of columns about teams. So then we can also look at 2000. So this means that 0 means a player wasn't drafted in the year 2000, while a 1 means a player was drafted in year 2008. And then there's also freshman, junior, sophomore, senior, whatever. So a 1 here means that this player was drafted as a senior. A 0 here means a player wasn't drafted as a senior. But yeah, likewise, a 1 here means a player was drafted as a senior. So we have a lot of columns now. Precisely, we have 402 columns, and that's okay. We can have a lot of columns from machine learning. That just means we have 402 dimensions. That's fine. And we have 32,932 players, and we have 402 attributes for every single one of these players. So now let's get to the machine learning part. This is the fun part. So first off, we want to know what we're predicting. So we're predicting this column. We're predicting whether it's a false or a true, whether the player played in the NBA or not. So we call this, in machine learning, we call this a label. So we're going to take this and set it equal to label. We're going to take the series and set it equal to label. We also have features. Features is everything other than the label. It's the stuff we're going to use to predict the label. So that's everything other than the NBA column, which I dropped to make features. So we have label and features. And now what we want to do is we want to do something called train test split. So what train test split does is it splits the data, the label, and the features into training data and test data. So you're going to have training features and test features, training labels and test labels. So you're going to have some data to train the machine learning algorithm on, and then you're going to have some data to test your algorithm on to make sure it's doing well. So generally, you want to have 20% of your data is for testing, and the other 80% is for training. And then the random state, unless you're doing research in machine learning, it doesn't really matter what you set random state to. I'm a big fan of Hitchhiker's Guide to Galaxy, so I set it to 42. Doesn't really matter. So yeah, what I get here is xtrain is the training data for the features. Xtest is the test data for the features. So basically, you just have features and you split it 80-20. The first 80% is you use to train your model. The last 20% you use to test, and likewise for the labels. So Y is labels, X is features. So now let's get to unsupervised machine learning. As I said, this is unstructured machine learning. So this is just trying to figure out some of the basic stuff. So what I want to do first is I want to reduce the dimensions. So right now we have 402 dimensions. However, a lot of the dimensions might be heavily correlated. So to get down the dimensions, what I want to do is I want to figure out how can we combine these dimensions to make a lower number of dimensions that are less correlated. So each dimension explains more variance, which is really important because if you have a lot of really correlated dimensions, that's first off not very useful, and that can screw with your algorithm. What I also want to do is I want to do something called standard. So if you want to look more into PCA, there's a whole mathematical proof of how to do it. It involves finding the eigenvectors, which is beyond the scope of this intro. And then we can also talk about standard scalar. So what standard scalar does is it scales the data to also everything is scaled the same, because if you have some data that goes from 0 to 1,000 and some data that goes from 0 to 1, the machine learning algorithm might get screwed up because of the high difference in range between 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 different columns. So what you want to do is you want to scale them so they're all pretty normalized. And because this is NBA data, there's not much to scale. I still scaled it, but sometimes you want to scale it manually. So sometimes you might want to look at it and see like, oh gosh, it's growing exponentially. So maybe you want to take the logarithm of that column or something. Anything you can get to make because machine learning algorithms like data that's more kind of incremental than exponential, because if you have a lot of really big data and a lot of really small data, that does it just from intuition, maybe it makes sense that like that's not something you particularly want. It can mess with the machine learning algorithm. It can kind of screw with the weights of the machine learning algorithm. So what I want to do is I want to scale. So I want to standard scale. So I want to scale the X train data, the training data for the features. And what I'm going to do is standard scalar dot fit transform. So I'm going to fit and transform the X train data so it's scaled properly now. And now I want to look at PCA. So I'm making a PCA object with 401 components, 0 to 401. So this is all 402 columns in my data frame. And now I'm going to fit transform my X train data. And now I'm going to try to figure out this PCA algorithm helps me find is how many features I should keep. So normally you want 95% of your variance to be explained, which is right about here. This is around 95%. So you want to keep this many columns, which I counted for you, and it's exactly 360 columns. So now let's get to supervised machine learning. So we know we want to keep 360 of the columns for PCA, and that's our unsupervised machine learning. Now with supervised machine learning, we're giving it a structure. We want to predict y test as best as possible using x test. So what we want to do is we're going to first try out logistic regression. So we're going to try out 3 supervised machine learning algorithms today. The first of which is logistic regression. So logistic regression is uses something called a logistic function to give a percentage or give a probability that something belongs to one class of objects and not another. So we're going to use logistic regression. So we set up our PCA with 360 components because that's how we determine the optimal number to be. And then we're going to set up a logistic regression model. So this model, I'm iterating for 10,000 iterations, and I'm giving no penalty. So you can adjust the penalty. There's multiple types. There's L1, L2, elastic net, elastic param, none, whatever. If you want to figure out which one does better, there's an algorithm called grid search, or you can just manually try all of them. I found for mine, none works the best, but some of machine learning is just trial and error to figure out which one works best for your problem. In this case, none works the best, but sometimes else you might want an L1 kind of penalty. If you want an explanation of what penalty means, you can just search it up online. Pandas is some really great documentation with logistic regression. So I'm going to introduce something called a pipeline. So what a pipeline does is it takes the standard scalar, it takes a PCA and logistic regression, and applies each of them one by one. It's kind of like a pipeline for your training data to go through all the way. So then I'm gonna fit my pipeline with X train and Y train. So I'm gonna train my model on X train and Y train, and then I'm gonna use my model to predict X test. So my prediction of X test is called prediction, and now I can compare my prediction with the actual result, which is Y test, and I get an accuracy of 97.4%, which is really, really good. Normally, like a 75% accuracy is even really good. And so 97.4% accuracy means that, first off, logistic regression is a really great way to predict whether someone's going to make it to the NBA or not. And not just that, but it's really easy to predict whether someone's going to make it to the NBA or not. And so let's introduce obviously this one's already really good, so you could just stop here. But I just want to try a couple more algorithms to give you guys a bit more feeling for the code. So also area under curve is just AUC, area under curve is just another way to measure how good an algorithm performs. The closer to 1 it is, the better. So I want to introduce a decision tree. So what a decision tree does is think of it as a flow chart. So basically at every point in the flow chart, if played more than 10 games, if more than 15 points per game, then he's going to the NBA or not. So it's more of a flow chart, and the algorithm will determine what's the best possible flow chart. And then when you're predicting, the algorithm is just going to follow the flow chart to help you predict whether someone's going to make it to the NBA or not. So then I'm going to make a decision tree classifier. So that's my decision tree model. And then I'm going to set up the criterion. So once again, if you want to know which criterion is the best, what max depth, what number of jobs, whatever the parameters you want to use. Just use something called grid search. Just search it up on pandas. That's a way to find what's the optimal set of parameters. In this case, this is the optimal for me. So then I'm going to use a pipeline once again. So I'm going to standard scale it. I'm going to apply PCA. I'm going to apply my decision tree classifier, and then I'm going to fit it on my. So I'm going to train my model on my X train and Y train, and then I'm going to use it to predict my X test and compare my prediction with the actual result, which is the Y test. And in this case, we got a 96% accuracy. So this is actually worse than logistic regression in this case. So yeah, depending on the problem, different algorithms might work better. So finally, I want to talk about random forest. So random forest is it's an amalgam of decision trees. So think of it as multiple. It's an ensemble. It's like an ensemble of like methods. Basically, think of it as like multiple logistic regressions, then decision trees combined together. So once again, to find the optimal parameters, just use grid search. Grid search normally takes up to an hour or 2 hours. That's why I'm not doing it here, but you should probably do it if for your own projects. And then once again, I'm going to use a pipeline. I'm going to standard scale it. I'm going to apply principal component analysis and get the optimal number of components. And then I'm going to fit my model. I'm going to train my model. So I'm going to train my model, next train and Y train. I'm going to predict X test, and I'm going to compare my prediction to Y test. And in this case, random forest is better than decision tree. And this makes sense because random forest is multiple decision trees. So what it will do is it'll reduce the odds that you're underfitting the algorithm. So odds that like your algorithm's too general. However, one issue is that this algorithm might get too specific. It might overfit. So it might look too deep into the data. And so as you get more experience with machine learning, you're going to want to better understand what each of the algorithms do. But today, what I presented you with for how to do some basic data science, as well as 4 basic models that you could integrate into your hackathon projects today. So I think we have 17 minutes left for any questions or anything.
If you guys have questions that you think of later or anything, again, feel free to just ask us on Discord.
Can the people on Twitch ask questions?
No, people on Twitch cannot ask questions. If you have questions you're on Twitch, please ask them in the Discord in workshop talking Q&A.
All right.
I think that'll do it for now.
All right, yeah.
Guys, if you have any questions,
can you post a document presented? Okay. Yeah. Okay, that's good. Yeah. I'm gonna head out now then.
Yep. All right.
Thanks
everyone for attending. Yeah. Thank you for your time. Have a great day, guys.